Take two of solving systems of linear and quadratic equations. Y'all would not just believe, well, you wouldn't believe what just happened to me. I went and recorded this video and I realized that I only had the screen on, computer audio on. I had no narration audio on, so I sit up here, made a video, and had no narration audio on. So this is take two of this video. Yeah, you didn't need to know that, but I told you anyway. But all for your learning. Yeah, I'm doing this for you, just for you. All right, solving systems by graphing. Let's review. If we solve a system of linear equation, linear means makes a line. By graphing, the solution is the place where both lines intersect. The solution should work for both equations. So in this equation right here, y is equal to x is the equation of this line. Y equals 2x minus 2 is the equation of this line. The solution will be 2, 2. And it should work for both equations. So when I substitute x and y, if I write it, I want you to write it. If I substitute x and y into both equations, y is equal to x. If I put y 2 is equal to 2, that's a true statement. It works. The point 2, 2 works for this equation. And then for the next one, y is equal to 2x minus 2. And if we put in 2 is equal to 2 times 2 minus 2. Let me slow down. I hear somebody saying, "You're going too fast, Mr. O'Neill." All right. So we get 2 is equal to 4 minus 2. And so 2 is equal to 2 is another true statement. So the point 2, 2 is a solution to this linear equation because it makes a true statement for both equations. All right. And also it is a place where both lines intersect. Okay. That's the first thing. All right, we have no solution is when the lines do not intersect. And so if the order for us to have a solution is to have the lines to intersect, if they do not intersect, there's no point of intersection, then there is no solution. And we know that with no solution problems, in linear equations, the slopes are equal. And the slopes of those will be -1. All right, so they do not intersect, which means we have no solution. Infinitely many solutions is when the graphs of the equation are the same line. All points on the line are the solution. So we have this equation right here, y equals 2x plus 4, and this equation y is equal to 2 times x plus 2. And when we simplify this, we get both of the same, we'll get the same line. All right, both lines are the same. And so I made this black line and I put the yellow line on top to emphasize that the solution is where the lines intersect. So the lines intersect at every point forever. These arrows mean that they go on forever. And since the lines are on top of each other, they will touch or intersect at the same point forever. Infinitely many solutions. Okay, all this underlining and stuff that I'm doing, I'm expecting you to do it as well. That's how you get your wonderful points for participation today. So what we're doing is that we're going into, I'm going to skip down. I think this is on the back. I'm going to show you what we're doing today. So I'm going to start here and then I'm going to go back up to the other part of the lesson. So on the back of the paper, you'll see that we're not talking about systems of linear equations. We're talking about systems of linear and quadratic equations. And we're talking about the solution to the system. And we can no longer say lines where the two lines intersect because this is a line, if I'm writing, but this is a parabola. So mathematical competent people now say the solution is where the place where both functions intersect. All right, so in order to do this, we have to go back and review one last concept. Turn your paper over. The zero product property. It says for any real numbers a and b, if a is equal to b, if a times b is equal to 0, then a is equal to 0 or b is equal to 0 or both a and b is equal to 0. Okay, let's review. So if we take two things and we multiply them together, two numbers who, well, in this case we have variables, and we multiply them together, the only way that we can get 0 by multiplying is to say that one of them have to be 0. So then a has to be 0 or b has to be 0 or both a and b are 0. That's the only way for us to get 0 by multiplying. So we want a trinomial like such to look like this. How can we make this trinomial look like a multiplication problem? We factor. That's how. So factoring, again, we have ax squared plus bx plus c. And we know if a trinomial is in this form, we can take when a is 1, we can take factors of c that add to give us b. That's what we're doing. So we don't need to use any fancy tricks here. We don't use slide and divide. You slide and divide, you slide and divide into 1. If you factor by grouping, you're using 1. So you're just doing extra stuff, but you'll get the problem. All right, so factors of c that give us b. So we factored this, so this will factor in. This sign says, hey, it's the same sign. This sign says, hey, it's positive. The factors of 9 that add to give me 10 will be 9 and 1. So we get r plus 9, r plus 1 is equal to 0. Now, I'm going to show you the math behind it, and then you use whatever little mental math tricks you can use in the future. It doesn't matter to me after this. But at this moment, I want you to write down what I'm writing down. So we get r is equal to r plus 9 times r plus 1 is equal to 0. It's very important. You can't use a zero product property without saying something is equal to 0. So you must say it's equal to 0. So we would say that this represents my A, this represents my B. I know I'm doing too much. Oh, well, you'll get over it. So we're saying that either A has to be equal to 0, or we're saying that B has to be equal to 0, or both A and B are equal to 0. So in this case, I'll use some mental math. R has to be negative 9, and in this case, R has to be negative 1. So if R was negative 9, it will make this equation equal to 0. If R was negative 1, it will make this equation equal to 0. Okay? So we will need that in the future, in the near future. All right, so coming over here, and of course, in the future, you can use your mental math in your head. All right, so n squared is equal to an minus 15. How do we make this look like a times b is equal to 0? We subtract an from both sides, mental math. And then we add 15 to both sides. And when we do that, that now equals to 0. We subtract an and add 15. When we do both of those, you get 0 on that side. So now, factors of 15 that add to give you negative 8. Well, there's only, and this sign says keep them the same, keep the negative sign. So we have n minus 3 times n minus 5 is equal to 0. And mental math, y'all, n is equal to 3 and n is equal to 5. If n is 3 or 5, you will get 0 in this case. All right, so now this brings us to the land where a is not equal to 1. When a is not equal to 1, we have to now ask ourselves, if this is a trinomial, is there a GCF in the problem? In this case, there is no GCF. Now, this is where we use our fancy tricks, and we go into the land of trickery with grouping and or slide and divide. I don't think y'all gonna do both, so it's got to be or slide and divide. And I'm gonna do both, and then I'm gonna give you a challenge problem to make sure you do it. All right, so I am gonna factor by grouping first. All right, so I take these two, because I know Ms. SR teaches grouping only, and we get negative 30x squared. And we break down negative 30x squared into factors that will add to give us 13. Well, those factors will be a positive 15x and a negative 3x. And then we bring down, my kids call this the butterfly method, especially fourth block. The butterfly method, because it looks like a butterfly. Yeah, mine are special, I know. All right, so then we get 6x squared plus 15x minus 3x minus 5 is equal to 0. We'll deal with that in a second. All right, so now we factored this GCF out of these two, factor by grouping. This is the grouping part. We group the first two terms, group the second two terms. Yeah, and then we factor out a 3x, and we end up with 2x plus 5. Yeah. Oh my God, I wrote down a 3. It's supposed to be a 2. I was like, something ain't working out. Yeah, I know y'all caught that mistake beforehand. I was like, what in the world? And then factor out a negative 1, and we get 2x plus 5 is equal to 0. Hopefully y'all caught my mistake before I did. I know some of y'all did. It's like, that's not 3, that's 2. And I caught it as well. All right, so we end up with 3x minus 1 times 2x plus 5 is equal to 0. And so, again, you use the factor by grouping, and then we have to use a zero product property. And so this is where the shortcut comes in. Some of y'all will set both of these equal to 0 and solve. I'm going to show you a little shortcut. Take the opposite of this, which is 1, and divide it by this, and you should get 3, and you should get x is equal to 1/3. Take the opposite of this, which is -5, and divide it by this, which is 2, and we get x is equal to 5/2. All right, so in essence, the math behind it, if you get 3x minus 1, I'll show y'all this on one problem. In order to solve this, you'll add 1. You don't have to write this down, and you get 3x is equal to 1, divide by 3, divide by 3, x is equal to 1/3. So I just showed you a shortcut. All right, to my students that use slide and divide, Miss Henderson students that use slide and divide, please make sure that y'all factor out the GCF first. The slide and divide will be 6x squared plus 13x, this video is about to end soon, minus 5 is equal to 0. Slide and divide, slide you over, we get x squared plus 13x minus 30 is equal to 0. I guess you don't have to write this, y'all. And then factors of negative, that would be x plus 15. Notice they have many things in common. And then x minus 2, but we must divide. And then when we divide, we must simplify. Jeez, y'all, don't forget to divide. I'm not teaching this next year because y'all don't remember to divide, which makes a shortcut just so much work. Divide this by 3. And we end up with 5/2, and then divide this by 2, and we end up with 1/3. And the good thing about slide and divide is that your solutions are the opposite of these signs, as we saw in the last problem. So x is equal to -5/2, and then x is equal to positive 1/3. All right, so we're not going to do the challenge problem because it's going to take up too much time. I was going to let that be a challenge problem, whatever. The only thing with this one, you must factor out a GCF. So that's all I'll say about this problem, which gives you 6z squared minus 7z plus 2 is equal to 0, because there is a GCF between 12, 14, and 4. And then you'll use either factor by grouping or slide and divide. It doesn't matter to me. Use what you have to do. Just make sure you factor out the GCF. Goodness gracious, y'all. All right, so why do I need that, Mr. O'Neill? Because life is about to look like this. Turn your paper over. Here we are. We are solving this system of linear and quadratic equations, but we're not going to graph them, as we see. The graph is to teach us what we're going to do. We're going to solve this by the process of, what's another way to solve a system? Substitution. All right, so we're solving this by the way of substitution. So we are saying that y is equal to x squared minus 6x plus 3. I'm writing, you're writing. And we're saying that y is equal to 2x minus 13. Substitution says when we have one variable alone, we put it what is equal to in the place of the other variable. So all of this is going right there. So now we have the equation of 2x minus 13 is equal to x squared minus 6x plus 3. So we are substituting this into that problem, and now we're solving. Just like before, we bring everything over here. So we subtract 2x, and we add 13 to both sides. Subtract 2x. We add 13 to both sides, and now we will end up getting 0 is equal to x squared minus 8x plus 16. Let me stop, because we're using substitution. All right, so I substituted this here, got that, I moved everything over, and so I always move the linear to the quadratic side. That's just my little shortcut or trick or whatever, or rule for myself. You can do the opposite way, but you're going to have more work. All right, so x squared minus 8x plus 16. So we need to factor this. This is the zero product property, ZPP. All right, so now we have x. I'm going to write it the other way because I hate reading that way. My kids know that too. All right, so we get x minus 4 times x minus 4 is equal to 0. Ooh, this is a perfect square trinomial. Yeah, so we know x has to be 4 and only 4 because, yeah, that's the only thing that's going to give us 0. So Why does this make sense? Because I see that the solution is 4, -5. That's my x. My x is 4. How do I get my y? By substituting this in to one of my equations. Now, why would we come up here and put it here? No, it's too much work. Let's just put it here. They're both equal to each other, so it doesn't matter which one we put it in, but it's just easier to put it here, okay? So we get y is equal to 2 times 4 minus 13. That's what we're doing to get our y. So we get y is equal to 8 minus 13, and 8 minus 13 is -5. Will you look here? My solution is 4, -5 by the process of substitution. Now, this is the kicker. I told you with linear equations, we can have one solution, no solutions, or infinitely many solutions. Well, with quadratic and linear equations, we could have what? 2 solutions. If this line came through, and I'm trying to, let's draw a line to a point. Say, for instance, it went through here, and it went through here. Say, for instance, this was the line. All right? That was your line. So, here and here would be the solution. Well, how would you get that, Mr. O'Neill? Well, if you remember, when we factored, we got 2 solutions here. Okay? So we will sometimes get 2 solutions if the line intersects the parabola in 2 places. So how would I end up with 2 ordered pairs? Well, we will get x would be 1. And then we'll substitute 1 into our equation. If I looked at the equation, I may have a linear equation, I'll figure this out, but I'm not going to. 1 into the equation, and then we will get x is equal to, well, it wouldn't be 1 because it will be saying, yeah. X is be 1, and then we'll get x is equal to 6. And then we'll substitute that into our equation. And what are the y's? The y's at the x, when x is 1, your y would be -2. And when x was 6, your y would be 3. So there will be times we will get 2 solutions. And when that happens, then you must substitute your x values, put it into the linear equation, y'all. There will be times we'll get no solution, but I'm not going to tell you what that looks like because you should be able to visualize that. That'll be a challenge. All right, so there will be 10 problems after this that in maybe 10. It depends on what I make up because the video is almost 18 minutes long right now. So there will be problems that we have to solve, and whatever you get on your quizzes will be your grade. Simple as that. You can ask your friends for help, I guess, if you really need it. If you feel like I went too fast and I didn't explain everything, somebody around you may understand the problem. You're not copying, you're not cheating. But yeah, that's what we're doing today, and my signature is that this has been a great lesson from Mr. O'Neill, another beast mode production, and I am out.